Thank you for coming to this talk. I'm David Lane and I'm going to be reporting on some continuing research I'm doing with Etienne Rouwette, and a full paper is available from us on request. This is about the behavioural turn, a very significant feature of operational research, and my aim here is to apply behavioural ideas to system dynamics. The behavioural turn is about the limits of human reason, so to get us in the mood, here's an example. We all know that Galileo got into trouble. In 1632 he was tried by the Inquisition, found guilty and sentenced to indefinite house imprisonment. How did this come about? Well, at that time the established model of the universe was the Ptolemaic system. The sun, the moon and the planets held in great crystal spheres, all circling the Earth. But early in 1610 Galileo pointed a telescope at Jupiter and he saw this: Jupiter with bright stars in a line, and he noted down their changing positions. These are moons. They are rotating around Jupiter. So the Earth is not the centre of all motion, and there are no crystal spheres, or the moons would smash through them. Bertolt Brecht gives us a version of Galileo's response. Galileo thinks that the key thing is that his telescope gives proof that there are no crystal spheres. Anyone can use a telescope and see for themselves and reason for themselves, and so change their fundamental view of the universe. In Brecht's Life of Galileo, he talks to his mathematician friend about how people will react to that idea. I believe in humanity, which means to say, I believe in human reason. His friend is not so sure. The behavioural approach has a similar view about the limits of human reason. What I'm going to do in this talk is say why the behavioural approach applies to system dynamics, try to describe the scope of that application, and then talk about what we get out of applying it. So, to start off with the first of those, when I think of the behavioural turn, I think of Tversky and Kahneman doing decision theory things. Their paper, Judgment Under Uncertainty, has high school students being given 5 seconds to estimate that. Now, the answer is 40,000 and something, but the median answer they got was 512. But then, when people were asked to calculate this, which is the same thing, they got a different median. Now, Tversky and Kahneman thought that what's going on is that people are looking at the first few digits and guessing the answer, and because the first one looks smaller than the second one, and people are insufficiently adjusting, you get different media. So there is anchoring and adjustment and insufficient adjustment. Now look at the structure of this. First of all, people are not doing it right. They're not getting the right answer. Secondly, it's empirically observable that they do that in a certain way, a repeatable way. And there is an explanation for the phenomenon. Here it's based on presentation of the situation and a psychological theory. So error, empirical observation, explanation about human foibles or failures. Now that gets us to a fine paper in eJAW by Hämäläinen, Luoma and Saarinen. For 20 years now, system dynamicists have been asking questions about stock and flow relationships, what we think of as mental integration. We know that subjects are not very good at this, and there are various ideas of why they aren't, but generally we system dynamicists tend to deduce that people can't deal very well with accumulation unassisted, and so system dynamic simulation modelling is needed. So that's one of the reasons we exist. Now an example of that is the department store task, which you see here. You have an inflow and outflow of people into a store. Now most subjects can answer questions 1 and 2 about the flow, but fewer can answer question 3 about the stock and question 4 about people in the store. Hämäläinen and his colleagues, however, suggest that there are behavioural issues here. The curves trigger the availability heuristic. The option boxes are a queue, prompting some responses, not others, and people are cognitively overwhelmed. So they did 11 experiments in which they changed the questions to remove some of these, and they encouraged people to think more deeply, and also sometimes smoothed the graphs. what they observed was great improvements in the stock-related questions. And their conclusion was that it's not that people can't deal with accumulation, but that the presentation, the cues embedded in accumulation-related questions can significantly influence people's ability to deal with accumulation, and that this is explicable and empirically observable. It's straightforward to apply the behavioural turn to system dynamics. When I started thinking about it in 2013, I thought this applies all over the place. System dynamics has always had a large number of ideas with a behavioural feel, how people are not good with complex systems, how they are not homo economicus when they make decisions, but also positively how people can play with a model together and learn. Those ideas are all in industrial dynamics. And in fact, it seems to me there's a vast range of phenomena that we are interested in as system dynamicists. So let's look at that scope. I started out using Kahneman's rather pop idea of System 1, System 2. Some of you may know it. There are different ways of thinking about what to do. One of them is to use System 1, which is fast. We use gut feel, intuition. We draw on past experience. We rapidly compare things and pattern match and make a decision. An alternative is System 2, which is much more deliberative. It takes time to apply rationality and reason and study individual cases. Now, if you use that approach, you can apply it to bits of system dynamics, and you see the amazing breadth of applicability of behavioural ideas. So the famous limits to growth structure, we might say, oh well, a System 1 approach explains why people keep pushing on the reinforcing loop, unable to change from what worked at first to and understand why it's not working now. A System 2 approach might go, well, yes, this is what the past was like, it did work then, but something else seems to be happening now. We need to think again. Maybe there's some kind of limit producing these frictional forces. The second example relates to beer game and supply chain oscillations. System 1 might say, I'm under terrible time pressure, I have to make this order decision, I just have to get on. Oh, I've forgotten what past orders I've made. System 2 says, well no, clearly we need to find time and the place, even if it's just a bit of paper, to record past orders. We need to remember the supply line. And of course we in system dynamics know that it's the fact that the weight on the supply line isn't 1 that is a significant reason why you get supply chain oscillations. And there's a string of phenomena here that can be explained using the S1, S2 approach, and you can see it gets grander and grander in scale as you go down the page. Now from that, here is my first attempt to sketch the territory of system dynamics that a behavioural term applies to. I'll talk about 4 areas. First, how we encounter the world, then our mental models of the world, then what needs to be in our formal models, the ones that we build, and then how we work with those models and encounter the world again. I will outline this and give some examples of the phenomena. Encountering the world starts with experiencing it. We don't know what's there, we don't have all of the information, some of the information is delayed. That rapidly gets us into the question of mental models, the ones we have and how we use them. So here we have the idea that we're not very good with stocks and flows. We also get the work of Derner and Axelrod on the simple nature of most people's mental models, that they have short causal chains and little or no feedback. Over here are the odd things about human behaviour that we have to represent in a model. So here we find issues relating to how the use of information is represented in models. So Moorcroft's ideas from Herbert Simon on bounded rationality will be located there. We also may have to build into models the idea that people learn, change their goals, alter the information sources they use, the weight they attach to information sources. In other words, they are active social agents. Down here we find issues relating to people working with formal models, an explosion of them. A core one would be people's overconfidence in their intuition, which makes them think they don't need any kind of formal modelling support. Or the experience and anecdotes that we've collected about how to work with a group of people to elicit information for modelling. or how you need to find a neat way to summarize, to chunk the insight from a model into something that people can remember and use in their encounters with the world to influence the world. Now, there are lots of things going on in this at different levels. Etienne and I eventually decided that this is really little more than a mind map. It doesn't capture the system dynamics process very well, so it may be missing aspects of what we do that can be illuminated using the behavioural turn. We decided we needed a new framework, and that using this framework to see what else we can think about could be a good way to go. So we have entities. These are more enduring platforms in which information is configured or arranged, and processes, channels by which actions result in one entity or representation having an effect on another. The thing looks like this. This is the situation where we have no model. This is how we engage with the world and think about what's going on, try to understand our experiences and decide what to do. And to Etienne and I, this seemed to organise the activities in a better way. We drew on the literature about various models for how the system dynamics process works, and I'm sure you'll recognise elements of it. But in all parts of this there are behavioural effects, albeit at very different levels. Now of course we have to add what a formal model does, something slightly different, but still the framework is there, and it seems to organise the activities in a better way. Everything in that first mind map can be located on this diagram, but we found that we got new ideas about how the behavioural approach applied. A couple of examples. There's a large literature on the limitations of human rationality for each of the stages described in this figure. So when prioritising what to look at in the real world, people tend to seek out information that is more consistent with their own views. Well, Jane Austen sat at this desk 200 years ago and reported a similar phenomenon in her novel Persuasion. How quick come the reasons for approving what we like. And when it comes to mental models, Etienne observed that Eisen's theory of planned behaviour can be a really useful thing to apply to the process by which mental models are used to create decisions and actions. The more we thought about this, the more we thought that there was a great range of behavioural effects that we could refer to. So what does behavioural system dynamics give us? Well, features common to all of the elements in that new map that we created are these: that behavioural effects or phenomena are observable in experiments, that behavioural theories can explain the phenomena like the 8 factorial or the department store, and that they suggest how to start improving things. When we move from the physics of systems to the foibles and fallacies of actual people, we get these things. We get these 3 benefits, and any system dynamicist looking at that list would surely see the promise and get a little excited. And this to us is what is new. A little bit of rules for behavioural system dynamics. First of all, what we think of as 2 cheers for physics, not 3, 2 cheers for physics. There's a firm acceptance that a purely physical or mathematical approach does not capture all aspects of real-world problems. Secondly, the technocratic view is faulty, not because it is incorrect, but because it is incomplete, as Tinker and Lowe put it. You need a wholesale engagement with theories and findings from other disciplines, and combining 1 and 2. You need a recognition of the value of field and lab experiments, and a willingness to create integrated theories and approaches using 1, 2, and 3. What does behavioural system dynamics give? Well, human behaviour is central to system dynamics in its models and in decisions observed in labs and in the field. Behavioural system dynamics is useful when observed phenomena can be explained and improved. A systemic overview, such as the one we have tried to work on, could show where the gaps are and provide the foundation for a research agenda. But most of all, we think that behavioural system dynamics might be the best approach to improve practice. System dynamicists might be interested in doing this because really we're going back to our roots. Forrester talked about the counterintuitive behaviour of social systems. What could be more behavioural than intuition? So this is our attempt to get system dynamicists interested in the behavioural turn, to show the extent to which we are already doing it and have been benefiting from it, to see it as the best way to improve practice further. Thank you very much indeed for your time.